YouTube? Mr. Keen coming at you live, not from the studio today, no sir or ma'am. We are in the classroom. Okay, that's why I'm all spiffed up. Today, you're going to be learning about Half-Life, but it's going to be a little bit more complicated. So I'm going to call this video Half-Life Notes Part 2, because we are going to be continuing. So could you please write down the formula for Half-Life? So we have new amount equals the original amount divided by 2 to the power of the age divided by half-life. So, and here's my example. If you check 7-day-old meat in your fridge and the half-life of steak is 42 days and you bought 1 pound of steak originally, how much does the meat weigh now? Okay? So use what you know from the problem and plug it into the formula. We don't know how much it weighs now. We know that it was 1 pound when we bought it. And we know that it's been in the fridge for 7 days and the half-life is 42 days. Okay? This meat is not good to eat. It has started to decay. It has started to lose color. So we're going to see how much of the red meat, the actual original meat, is left. Okay. Here's my hint. I bolded all the important information. Please try and do it now. Okay? Please put in your calculator. Try and get the answer now. It should be a little bit less than 1 pound. If you did it right, the new amount, we don't know, but we do know that it was 1 pound when we bought it, and then it's 7 days old, and then the half-life's 42 days. So you do 1 pound divided by 2 to the power of 7 days divided by 42 days. If you do it right, you could reduce a fraction. You don't have to. And if you put in your calculator right, you get 0.89 pounds of meat. That's how much of the original meat is still left. Okay? Next, you found a decaying fish in your backyard. Someone threw it in your backyard, probably a hate crime, and you left it there for 8 days. And since you left this fish for 8 days, now you're curious how much it weighs. You notice it started to decay a bit. So, you don't have a scale, but instead you could do math and figure out how much it weighs in theory. So, you research the average half-life of a fish carcass to be 12 days. That's the half-life of a fish carcass, 12 days. If this fish, before it died, weighed 5 pounds, what does it probably weigh right now? So it used to weigh 5 pounds. It's been rotting in your backyard for 8 days, and the half-life is 12 days. Okay? So please do the math. Try and figure out how much does it weigh now? How much of the fish is left? Okay? Please plug in what you know into the formula and solve. Please pause it now. If you did it right, 5 pounds is the original weight. And then you divide it by 2 to the power of 8 days. That's how old it is, divided by the half-life, 12. And you're left with 3.15 pounds. So that's how much the fish weighs now after it's decayed. Next. Okay, if red meat has a half-life of 42 days and fish has a half-life of 12 days, I want you to guess. Pause the video now, think about which one of these will last in the fridge longer. Half-life of 42 days, half-life of 12 days. Hopefully you logicked it out. You realize meat will last longer in the fridge compared to fish. Not the freezer. The freezer will stop the decaying, but the fridge, the meat will last longer. The meat won't decay by half for 42 days. The fish doesn't take as long to decay. It will decay a lot faster. So therefore, your fish will go bad a lot sooner. If you buy fish and put it in the fridge, you better be cooking it that night. Whereas meat, if you put it in the fridge after you buy it, you have like 2 to 5 days. Okay? And the reason why I'm telling you this is because I want you to write down things with shorter half-lives. So things with smaller half-lives are less stable. They're going to break down faster. So if it has a shorter half-life, it's less stable. So like, for example, strawberries, they go bad really fast. Short half-life, unstable. Garlic, very long half-life, very stable. They don't break down very easy. Breaks down very easy, does not break down very easy. Okay. And hopefully you watched my video going over algebra review, because you need to know logs for the next problem. Okay? So if you don't know how to do logs or how to use them, please watch the last video I posted. Okay? Because we're going to skip the algebra review and go right into the next half-life problem. This half-life problem is very difficult, but if you understand logs very well, then you should be able to solve it. Okay? So it'll take a lot of steps, and I'll be showing you in the video. All the previous problems you were solving for new amount, but now you have to learn logs because you're going to be solving for age, and age is in the exponent. We don't know what the age is, so you have to solve for it using a log. Let's read the problem. You are hiking and trip over a fossil. This is actually how we discovered Lucy. You discover the fossil has 25 grams of undecayed carbon atoms now. So it has 25 grams of undecayed carbon now. If you add and do some math and backwards calculate how much it weighed based on the decayed atoms, you find that the original fossil weighs 1,500 grams. If the half-life of carbon is 1,000 years, how old is the fossil? Okay? Please pause the video now and try and do it yourself. This is going to be a hard one, but I just highlighted all the information you need. So the new amount is 25 grams. The original amount is 1,500. We don't know the age. We don't know how old it is, but we do know the half-life of carbon is 1,000. So please try and do it. Pause the video now. If you did it right, here's the information you need. If you plug it in, the new amount is 25. The original amount is 1,500. We don't know the age. We do know the half-life. So here's the formula that we have. And your job, this is the algebra part that I really wanted to go over. We need to get age by itself. We don't want this attached to all these numbers. We want age by itself. So first thing we're going to do is we're going to move this whole thing. We want this whole thing by itself. Okay? Okay. I'm going to get rid of that. Okay. Next. So, to get it by itself, we multiply both sides by it. So, sorry, I'm playing around. I'm trying to find something I like. Okay. Nope, don't like it. Okay. So, what we do, we want this by itself, so you multiply both sides by it. And if you multiply this by itself, it'll cancel out, and then it'll move over to this side. So basically what we did, here's a formula. We wanted this part by itself. So we multiplied both sides by this, and then this canceled out with itself, and it moved over here. So 2 to the power of age divided by 1,000 times 25 equals 1,500. Now we want to get rid of the times 25. We don't want this pesky times 25 over here. So what you do, you divide both sides by 25. Because we don't want this times 25 over here. So if you divide both sides by 25, you get 2 to the power of age over 1,000 equals 1,500 divided by 25. 1,500 is the original, 25 is the new amount. Okay. We still want to get age. And this is why you need to learn logs. Because right now we're stuck. We need to drop down the exponent. And to do that, you need to convert it to log form. If you don't know how to do that, watch the video. So, 2 to the power of age divided by 1,000 equals 1,500 divided by 25. You convert to log form. So this 2 gets pushed down under the log, and then the age divided by 1,000 swaps places with this one. So then log base 2, 1,500 divided by 25 equals age divided by 1,000. So that's what we have next. And the age still isn't by itself. It still has that divide by 1,000. So to undo divided by 1,000, you times by 1,000. And if you put log base 2 this on the calculator, you get 5.907. And to get rid of the 1,000, you multiply both sides by 1,000. And you get the fossil is 5,907 years old. That's how the scientists do it. They do have to do some math. And here's a summary of all the steps that it took to do it. Okay? Yep, that is the last thing. That is as hard as these half-life problems can be. Okay? If you did this all by yourself, you're the master at it. I can't give you anything that's harder. But we will practice it more tomorrow. And that's how you do it. Step 1, you wrote the formula out. Step 2, you rearranged it so it looks like this. Step 3, you converted it to log form. Step 4, you typed log in your calculator, got this, and then you times it by 1,000 to get the age of the fossil. Cool. Thank you so much, everyone, for sticking with me the whole time. I appreciate it. Have a great day.